Welcome back to all. Now let us look at manufacturing cells. A manufacturing cell is a grouping of all required machinery to produce a single product. Let us look at an example from food industry. Many of us may know Subway Eatery. A Subway restaurant can also be described as a cell. All the ingredients for the sandwiches are stored in a systematic manner, so that the person serving can access them easily. The customer can take the sandwich and go to a seating area without wasting a lot of movement or walking. Why a manufacturing cell? Let us look at why a cell is needed in place of traditional manufacturing setup. The process type of layout does not help the production to flow, and, by design, it encourages overproduction. It simplifies scheduling and communication. The manufacturing cells are focused on the products that are taken up in the cell. The manufacturing cells also build in a good amount of flexibility to handle various products. Cells also can help handle more or less volume of the same product, either by adding or removing operators. The cells minimizes the NVAs. It improves the visibility. It enables smaller lots and sometimes single-piece production. Steps in designing a manufacturing cell. When your layout is traditional and when you want to shift to a cellular manufacturing, you need to do it in a systematic manner. There are some steps that need to be followed in designing a manufacturing cell. Step 1. Group the products. Step 2. Decide the capacity of the cell. Step 3. Establish optimal process sequences. Step 4. Design the cell layout. Let us look at each step in detail. Now let us look at other considerations for a good design. Ergonomics in manufacturing cells. As the manufacturing work is done repetitively, the movements that operators make are to be studied closely. A difficult body movement, while is okay when you do once, it would be harmful to the human being when it is done repetitively. Let us understand some of the health disorders that are related. These are all the disorders that can develop when a particular movement is done regularly and repeatedly. The manufacturing cell design and work design should consider these disorders and avoid them. Today, a number of simple automations are possible to ensure the humans involved are fully protected. Example: instead of manual tightening of nuts, electrical or pneumatic nut runners are available. Where it is not possible to use a nut runner, the engineers in the company have to design simple automations in an innovative manner. Let us look at some don'ts with regard to ergonomics. Backhand push, twisted body, pushing behind, twisted arms. Risky action and position examples. Wrist flex. Hook grip is better than pinch grip. Bending at hips and waist. Reaching and pushing forward with wrist twist. Reaching above shoulders. I am sure you can understand that the people who are designing the manufacturing cells or work areas have to be aware of the ergonomics as a serious subject. They should refer to the recommendations of bodies that have done some good research into this area. OSHA's is one standard that talks about ergonomics. Next, let us look at how to design workplaces. Human dimensions in workplace design. Humans vary significantly in size and build. In some situations, it is sufficient to design for smallest or largest likely dimension. In other situations, adjustable benches, chairs, or devices are required for a full range of people. Note that these dimensions are from older studies of North American and primarily Caucasian personnel. Good examples of workplace design will consider these recommendations. For works that involve accessing material or tools regularly, the design of where to put what materials is very important. Due to repetitive nature of work, a bad design can have a very adverse impact on human body. Sometimes, the work may have to be done in restricted places in manufacturing, especially if it is maintenance work, where the equipment that has to be attended may not give lot of space to the operator concerned. But the machine manufacturers and installation engineers should consider these recommendations. These illustrations and recommendations are taken from E.J. McCormick's works.